Welcome to the video, What is Pi? Pi has to do with circles, and everybody's favorite circle is the fidget spinner, correct? Or maybe that was so 2017. Before we get into what is pi, we are going to talk about division. What is division actually doing? Well, if you think about division in terms of the put into model, we ask ourselves, how many times does 2 fit inside of 8? So instead of like saying, oh, 8 is cut into 2 parts, we're saying how many times does 2 fit inside of 8? Well, it fits in there 4 times. 2, 4, 6, 8. So there's 4 of these 2's living inside of 8. So then we can say things like 8 divided by 4. Well, how many 4's fit inside of 8? Well, there are 2 of them. And then we can ask the question, 8 divided by 1. How many 1's live inside of 8? Well, 8 of them. But then this leads to fractions. 8 divided by a half. This one's a confusing thing because we're actually going to get a bigger number. Why do we get a bigger number? Because we're answering the question, how many times does a half fit inside of 8? So how many times, if you think about this as like a 50-cent piece, so this is like 50 cents, right? So there's 50 cents, and then you're putting it into fitting inside of $8. So you go like 50 cents, $1, etc. Well, that would be 16 of those. There's 16 50-cent pieces that fit inside of 8. So that is the put into model for division. Well, that's what we're going to do here is we're going to ask the question, how many times does the diameter, how many times does the diameter fit around the circumference? So the circumference is the distance around the outside of the circle. So we're going to do circumference. Now remember, I'm a math teacher, not a English teacher. Circumference divided by the diameter. So we're going to figure out how many times the diameter fits inside the circumference. So how many times does it actually do that? So the diameter is the distance across the circle, and the circumference is around the outside edge. So I'm going to make a starting point here, and we're going to put the diameter, make it fit around the circumference. So that's pretty close. So it fits once, and then we make the next diameter go here, and you like my orange? I feel like I'm the Denver Broncos. The Denver Broncos aren't in the Super Bowl this year, so I'm supporting the old Peyton Manning here. So we got the blue and the or maybe it looks like the Dolphins more. So we're to put our next mark there. So there's 1 time, 2 times, and then we see it's going to go a little bit more. Is it going to go a whole 3 times here? So we got the diameter fitting around the circumference, and there, pretty close, right about there. Boom. So it fits 3 times plus a little bit more. A little bit more. And what it turns out, math people through the ages discovered that it always, no matter how big or how small the circle is, the diameter always fits 1, 2, 3 times and a little bit more. Well, you guessed it, that's the constant pi. So pi, we abbreviate it as, well, we use the little squigglies here for means approximately. 3 times it goes around plus 1, 4. And there's lots of different estimations for pi. In fact, I'll show you some crazy ones here in a minute. One of the ones that I used back in the day was pi was approximately equal to 22 divided by 7. That one people don't hear about too much because they use the decimal one. But it's more than just these numbers. It actually never stops and never repeats. So the diameter fits into the circumference 3 times and just a tad bit more, just a little bit more. So the circumference divided by the diameter, d, is equal to pi, this ratio. So pi is a ratio. A ratio is when you take, is a fraction. You take two things and compare them. So it's a comparison of the circumference, the diameter, and it also talks about the put into model. So how many times does this fit inside of here? This fits inside of here 3 times and a little bit more always. Well, then this isn't very convenient, so typically the way you see this in a math book is through the power of algebra. This d gets moved over to the other side of the equation, and we say c is equal to pi times the diameter. And that's the formula for the circumference. So circumference is equal to pi times the diameter. Now let me show you some crazy wacko estimations for pi. Let me pause it here, and I'll be right back. As promised, here are the other famous fraction estimates for pi through the ages. This one is from 1583, as you can see. There's the 22/7. That goes clear back to Archimedes, who is ancient Greek. And this is my favorite right here, Ramanujan. I believe he was an Indian mathematician. This was his estimate for pi. So that's my favorite one because it has square roots in it, which are irrational numbers, and pi is an irrational number as well. Okay, and there's one more that I want to find. This is from a calculus book, and I teach calculus too, so these I found in this calculus book, and they're kind of fun. And there's one more I want to show you. I'm going to pause it here and come back. Okay, here's the next one I wanted to show you. Pi is equal to 4 times this quantity right here, and this goes on forever. That's what the dot 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 means. So if you do 1 minus a third plus a fifth minus a seventh plus a ninth, forever and ever, that is exactly what pi is equal to. It's through the magic of calculus, you can make this true based on things up here. This famous series obtained by Leibniz, a German mathematician, in 1647, shortly after the conceptual understanding of calculus. So, to sum this all up, what is pi? Pi is the ratio of the circumference. I'll refocus my camera here. It's the focus. It's the I did focus the circumference divided by the diameter. So how many times? 1, 2, 3 times and a little bit more is for every circle, no matter how big or how small. You can test it yourself. Make a giant circle, run the diameter across. It's always 3 times and a little bit more. Wouldn't it be perfect if it fit in there 3 times? But that's just the way it is. So c divided by d is pi. Circumference is pi d. Hopefully this has been helpful, and I'm going to add to these, but today we learned about what is pi. Woo!